So we have now here a parallel DC circuit. So 3 resistors R1, R2, and R3 are now connected in parallel with, say, a total voltage source of VT. So we have here a total current IT produced by this voltage source, and upon this node there will be some current that will be flowing through this resistance, say I1. Then there will be current flowing through this resistance I2, then current I3 for the resistance R3. Then of course we can measure voltage across this resistor, say V sub 3, pertaining to the voltage across resistor 3. We can also measure voltage across this resistor V2 and voltage V1 for the resistance R1. So again, we're trying to get the relationship between these parameters. So parallel circuit is governed by certain laws. So the laws governing parallel circuit. First is about the total resistance. The reciprocal of the total resistance is actually equal to the sum of the reciprocal of individual resistances, meaning that is 1 over R1 plus 1 over R2 plus 1 over R3 plus, if ever there are more than 3 resistors connected in parallel. So applying your mathematics, it could be represented by R total inverse, R1 inverse plus R2 inverse plus R3 inverse plus inverse plus Rn inverse. But I want to solve for R total, not R total inverse. So what you're going to do is raise both sides to the -1, making this as R1. -1 to the -1 is R1. So this is R total. So you have here R1 inverse plus R2 inverse plus R3 inverse plus Rn inverse. Then the answer inverse. How about for the current? So you will notice here that this current I total coming from the source will be divided into 3 again. Not necessarily, or doesn't follow that is divided equally. This will be divided accordingly based on the value of the resistance. So again, the resistance is inversely proportional with the current. So the larger the resistance, the less current that will flow in each branch or in each resistor. Now, meaning, if you solve for the I total, that is simply the sum of all the currents in each branch. So if ever I have more than 3, so that will be the sum of all the currents. Number 3 is the voltage. Based on the ruling, this voltage V3, if you're going to measure current here, or voltage here rather, that will give you the same voltage as you measure at this point and the same at this point, which is equal to the total voltage. Meaning, the total voltage is equal to the voltage at resistor 1, voltage at resistor 2, and equal at resistor 3, or equal to any voltages across each resistor as long as they are connected in parallel. And for number 4, how about the power? So using equation number 2, or maybe I may use equation number 1, but for the convenience of the solution, I may use number 2. If I total is equal to I1 plus I2 plus I3, again, let me consider just 3 resistors. If I'm going to multiply both sides by V total, because V times I is power, then I will have I1 V total plus I2 V total plus I3 V total. And again, based from rule number 3, the voltages are equal at any resistance. Then this is V1 I1 plus I2 V2 plus I3 V3, and the current through resistor 1 multiplied by its voltage is power absorbed at resistor 1 plus power at resistor 2 plus power at resistor 3. When you add these 3, it gives you the total power. So again, if you have more than 3, you can add all the power. So to generalize, regardless if the resistors are connected in parallel or in series, you're just going to add the power. Example, say I have 3 resistors connected in parallel, and let me use the same value of resistor 10 ohms, R2 as 5 ohms, and R3 as 3 ohms for comparison later. Of course, connected with the same voltage, the only difference is they are now connected in parallel. So again, there will be a total total current IT, there will be current I1, I2, and I3 flowing through resistance R1, R2, and R3 respectively. So my requirement now is to solve, same requirement, let us solve for the total resistance, B, total current, C, current I1, say the current at resistor 1, current at 2, and current at 3, D, I want you to solve for V1, V2, and V sub 3, the voltages across each resistors. Then E, to solve for the total power. So the solution will be for A, so the total resistance or the reciprocal of the total resistance is equal to the sum of the reciprocals of its resistances. So this is R3, or can I say R total is simply 10 inverse plus 5 inverse plus 3 inverse, and the answer inverse. So using your calculator, 10 inverse plus 5 inverse plus 3 inverse, that is 30 over 19 ohms, or equivalent to 1.5789 ohms. So if ever hindi nyo maiwasan na gumamit ng decimal, better to have it in 4 decimal places. Okay, so we have now our total resistance. How about for letter B, the total current? Again, to solve for the total current, let me use the Ohm's law. So total voltage will be 12 volts divided by 30 over 19 ohms. The I total is equal, so that will be 12. This is 7.6 amperes for your total current, and therefore it follows that if you're going to solve for I1, by the way, you cannot just solve for I1, you have to solve first for letter D, the total voltage, that V1 is equal to V2 is equal to V3 is equal to V total, that is how much? 12 volts. So to solve for I1, let me use the Ohm's law, V1 over R1. So V1 is 12 volts divided by R1. 10, right? So you have 1.2 amperes. That's your I1. I2 is V2 over R2, again using the Ohm's law. I2 is equal to V2, still 12 volts, divided by 5 ohms. I2 now is equal to 2.4 amperes. Lastly, I3 is equal to V3 over R3. I3 is equal to how much? 12 volts divided by 3 ohms. Then I3 is equal to 4 amperes. Again, to validate your answers, you may refer to the principle. It says that the total current is equal to the sum of the individual currents in each branch. So, when you add I1 plus I2 plus I3, is that equal to the I total? Just for checking, yes. 1.2 plus 2.4 is this 3.6 plus 4 is 7.6. Yes. Okay. How about solving for the power? Solving for the power, can I write it here? Solving for the total power for letter E, total power is equal, say, using the formula I total V total, that is 7.6 amperes multiplied by 12 volts. Then power, 7.6 times 12 is 91.2 watts. So this is the value. Now, purposely, I used the same value of resistors, 10, 5, and 3 ohms respectively, connected with the same voltage, 12 volts, for us to compare. It's very clear when I solve this in terms of series, it gives a total power consumption of just 8 watts compared to 91.2 watts of parallel. So obviously, that is the advantage of connecting your loads or resistances in series. It's obviously consume a much less power compared to the parallel. But again, the purpose or the priority of engineering practitioners, of course, above all, is safety, and secondly, the continuity of service. So, although in terms of its consumption, it's very much cheaper, but how come the other factor? So let us discuss now the advantages and disadvantages of using parallel and series. So series circuits, actually, the disadvantage of using series is that, say, I have here 3 resistors connected in series, say through a battery or a source po. So if ever happens na nasira tong isang to, say na-open dahil siya nasira, the rest of the circuit, although siya ay hindi sira o gumagana pa rin, I mean in good condition, the whole circuit ay hindi gagana kasi nagkamera ng open. So that's the problem with series. And in practical use, or commonly, Christmas lights, often referred to as series lights, are connected in series. Why? In terms of its consumption, is very little. Pero, di ba, kapag yung Christmas lights, nasira yung isang bulb or nakulangan ng isang bulb, the rest nung nasa linya ay hindi naiilaw. So, that is the disadvantage naman of using series circuits compared to parallel circuit. Say, I have here a resistor connected across a voltage source. I have here another resistor. If ever there will be a problem, say, in this resistor, so, na-open siya kasi nasira siya, say, bumbilya, nasira to kasi napundi, the rest of the other remaining resistors will actually function kasi there will be current flowing through this resistor. Wala lang dito kasi ito yung open. Samantalang dito, kahit nagpa-function pa yung, in good condition pa yung dalawang resistors or load mo, nasiraan ka lang ng isa, wala lang kaganang kuryente dito kasi this part is open based on the principle we have discussed. So that is the advantage naman of connecting parallel instead of series. So again, in terms of consumption, much cheaper in terms of series compared to parallel. But again, as our prime priority, second to safety is the continuity of service. So it's very impractical for us practitioners to connect our loads in series for a sole purpose of less consumption.